This is Miss Baudin Faras from EC third year. Today I am going to give seminar on the topic of Yagi Uda antenna. So firstly starting from contents. The contents are introductions, structure, elements, working designs, characteristics, disadvantages and applications. So introductions. In the 1926, Dr. Sri Andrew Uda and Dr. Heiratsu Yagi of Imperial University invented a directional antenna so array of the coupled parallel dipole most higher gain antenna. Yagi Uda antenna is familiar as kind of turn TV antenna to be found on rooftop of house. It is used as frequency between 30 megahertz to 3 gigahertz to cover 40 to 60 kilometers. As you can see, this is a structure. The black color is a boom. The green color is darkness and red color is driving element. Blue color you can see that is reflector. This is structure and we are going to elements. Number one is reflector. In that we are having passive element. It adds up the field driving elements in the direction from towards the driving elements. Second one is driving element. In that we are having active elements. It is an resonant half wave dipole. The elements are feeder supplied to charge. And third one we are there is directories. In that we are having passive elements. It can be one or more. For increasing their size is 5% less than driving element. So this is working of Yagi Uda antenna is an array of driving element, one or more passive elements. These are not connected directly to the TX line but electrically coupled. Current flow in the driving element includes voltage. The phases are phase current flow depends upon spacing and reacts of elements. Spacing are in the order of 0.1 lambda to 0.15 lambda. This is the diagram combining of effect reflector and director elements as highly directional antenna is obtained over here. You can see direction undesired beam radiation, and this is a desired beam radiation. Feeding line is over here and the distance is 0.1. You can see now we are going to a design. Reflector length is 500 by f megahertz. Driving element length is 475 by f megahertz. And lastly director length, that is 455 by f megahertz feeds. So conditions are the reflector length is 5% more than the driving element, less than lambda by 2, so it leads to inductive. Second one is the director length is 5% less than driving element, so in that case less than lambda by 2, so it leads to capacitive. Radiation patterns, you can see over there the diagram of Yagi Uda antenna, and this is the direction of main beam. This is the vertical diagram. Here you can see horizontal. Here you can see disadvantages. Gain is not much more and needs more driving elements for longer distance, and in this case bandwidth is limited. Now we are going towards the applications. Undesiralization beam of a moderate directives. Second one is gain of the order is 8 dB. Front back ratio is about 20 dB. Beam antenna is 3 element, and further element increase directive increase, and construction is very simple, and it costs it less cost as and simple to fit. Thank you.